In this video, I'm going to show you how I draw Bohr models. And the first thing we're going to do is take a look at the paragraph at the top, because sometimes we just skip past that and it actually has some really good information. Something we already know, protons and neutrons are equal because they are neutral. We also probably already know or have heard before that protons is determined by the atomic number on the periodic table. When adding electrons, you add them to the lowest energy level first, which is closest to the nucleus. You keep going until you match the number of protons, and I will show you how to add them individually till each is half full. A little review. Probably have heard this before as well. For the first energy level of electrons, the first ring, we're going to add 2, the second 8, and the third 8 as well. Our first element is hydrogen, and this is hydrogen's 1 proton in the middle there. It's got an atomic number of 1. And if you look at this particular example of hydrogen, you can tell how many neutrons it has just by looking in the nucleus. There are no other circles, so this has no neutrons. And we know that the protons and electrons are equal, so I've got to put a 1 here. I can also tell that there's 1 energy level because I have 1 circle. And then I'm going to add my 1 electron simply by putting a dot there. Now that dot's a little bit large. I probably should have made that a little smaller. I'll fix it for the next one. Now we're looking at lithium. Since there are 2 rings, we're going to say that there are 2 energy levels in lithium. Looking at our periodic table, we find out its atomic number is 3, which also means it has 3 protons, also has 3 electrons. If I were to color in 3 of my dots, 3 of my protons here, it's hard to get exactly on there, I will see that I have 4 neutrons left. So now we're going to draw our electrons. We said we would add 2 to the first ring, and then my third goes on the second ring. All right, now we'll go to sodium. And I see I have 3 rings this time. And on the periodic table tells me that Na has an atomic number of 11, which means 11 protons, 11 electrons. And we got to find out how many, after we color in 11 of these, how many are left to be neutrons. It'll probably be easier for you to just do this on your own. 3, 4, 5, 6, 7, 8, 9, 10, 11. And then if you just count what isn't colored in, I count 12. And now we're going to add our electrons. We got our first 2 on the first ring. And in the second ring, our note said we could have up to 8. So I'm going to start by keeping them unpaired as long as possible. There's my 4. Now, once I get to 4, I've got to start making pairs. So here's 5, 6, 7, 8. 2 in the first, 8 in the second gives me a total of 10. But remember, I need 11. So I'm going to add 1 more to the outer ring. So we're going to do some of these together, and I encourage you, as soon as you know what you're doing, just turn the video off and do it on your own. But I'm gonna get you started. Hydrogen is already done for you right here. Remember how we take the number of protons and we just put it in the middle. Otherwise, you're going to be drawing dots like on the other side of the worksheet, and that's just not necessary. So we've got helium here, and to help you out, it tells you how many protons there are. So we do a 2+, and we're going to do our 2 electrons. I'm going to do them over here because I have a little more room in that ring. We go on to the next row. When we move on to another row of the periodic table, that's when we add another ring. So for lithium, we've got 3 plus here in the middle. And we've got our 2 electrons in our first ring, and then we have our 3rd electron in the outer ring. And I'll tell you what this number of VAL means in just a bit. All right, beryllium, we've got 4. So basically you take the atom right before, and you just add on 1 more dot to it. So they go up one at a time. So like when we do boron, we're going to have 5 here in the middle. And then, so we'll do our 2, and then 3 more gets us to 5. So this looks just like beryllium, except with 1 extra dot. All right. I'm going to go ahead and put in all my protons here in the middle. And then we've got our 2, and then we need 4 more to get to 6. For nitrogen, this is where, once we get to the 6, then we begin to make pairs. So we will put our 7th electron as a pair for nitrogen. Oxygen. So we have the same pair as before with nitrogen, but we'll have 1 extra pair. Fluorine. And then finally, when we get to neon, we'll have 10. So we will end up with our outer ring being full. Because remember, the maximum it could hold was 8, and now it's with 2 in the first, it needs 8 in the second. I'm going to go ahead and show you what valence means. Right here it says valence electrons are the ones in the outermost energy level. So you simply look at the ring and you count how many there are in the circle that's farthest from the nucleus. Helium only has 1 ring, so those 2 are valence. Lithium, though, we're going to ignore those 2 in the first ring, and we're only going to count this 1 in the outer ring. Beryllium, 2 in the outer. Boron, 3. You probably notice a pattern here, and that's good. You want to be able to see as many patterns as possible in the periodic table. You'll see another pattern start to happen when you go down here to sodium, number 11. We've got 11 protons. Sorry, I had just a little technical difficulty there. We were on Na, and we were doing 2 in the first, 8 in the second, and then our 11th goes on the 3rd ring. And then the pattern, we said 1 valence here, 1 for lithium, and then we also have 1 for Na. So we see a pattern going in groups or families vertically on the periodic table. We'll do just a couple more together. Again, you may be ready to just turn this video off. So magnesium now has 2 in the outer ring, and that's why it has 2 valence. And aluminum has got 3 in its outer ring. And just remember, when you get to phosphorus, P, that's when you'll have to start pairing up your outer electrons. But you should also note the pattern going across the row of the periodic table. You will have a test question that asks you to describe the patterns in groups or families, so that's going this way. And you can tell me about the rings, you can tell me about the valence electrons. Same thing going across the periodic table, across the period or a row. Tell me about the rings and the valence electrons. And that will be the essay question on your test this chapter.